Welcome back. We're going to do another problem. And this time it's a weak acid versus a strong base. How do I know? Because this is not on this list of 6 strong acids. So that's weak acid. This is a strong base. Since the acid appears first and the base appears second, we're adding base into an acid. And as always, you should balance. And if you do, you'd see that you end up with this. Good. Now, we have to find the equivalence point volumes. So V acid times C acid equals V base times C base. Okay. Volume of acid is 25 mils. Because that information is what is stacked to H3PO4. And concentration of acid is 0.5 molar. Volume of base is what we're really trying to find. Concentration of base is 0.25. Well, the base contains the 3, so we multiply the acid side by 3. This was an easy question on exam 2 that I think a few of you missed, which is a crying shame because it's a point that you can get without making a sweat. But hey, you prefer the hard way to get the problem wrong. So anyway, so X is 150 mils. So this is your equivalence point volume. I don't know. I feel bad that you don't get this one. You know, I regret that you don't get this type of problem right on an exam. What is there really? I mean, I even gave the expression. You got to do is put them in the right balance and put the 3 or 2, whatever it is. And I don't know. This is to me like this is explained to me this way, I would definitely get this problem right on an exam. But hopefully, you know, there's still the final. So, all right, qualitatively draw the titration curve. Okay, we're going to draw first the X and the Y-axis lines. All right, we're adding base into an acid because base appears second. So volume of bases in the X-axis, milliliters. pH is always by default the y-axis. Put 14, 7, and 0. Okay. This is a triprotic acid, and we're adding base into an acid, so it's bottoms up. So it's going to go this way. It's a triprotic acid, H3PO4. You got 3 hydrogens, right? So it's triprotic. It means we will have 3 inflection points. So just go 1, 2, 3. So 1. Every time this flat portion should be a little smaller. Although, you know, that's attention to detail. If you don't do it, hey, it's okay. There's not going to be 10 problems. Then graphs in the multiple choice, there's going to be only 1 or 2. So anyways, that's how you draw the qualitative. I will rather finish the second problem in this video as well, so it saves time because I got time on this video. All right, so this is a weak base versus a strong acid. And I think it's 1 to 1 to 1 to 1 to 1 to 1 to 1. Okay. And again, V acid times C acid equals. Now finding pH is a different story, but finding equivalence point volume is always the same. I mean, you just have to account for the 1 or the 2 or the 3, but in this case it's 1. It's even easier. So this information is tagged to the base, so we know volume of base is 25 mils. Concentration of base is 0.5 molar. Volume of acid is X, which is what we're trying to find, and concentration of acid is 0.25 molar. And so X would be, you don't need to multiply anything because it's 1 to 1. So 0.5 times 25 divided by 0.25 is 50 mils. All right, that's that part of it. Now qualitatively draw the titration curve, same as always. Now you won't be drawing this because keep in mind our test is multiple choice, but you have to identify the correct graph. So that takes a little bit of thinking. So 14, 7, and 0. And we're adding acid into a base. So x-axis is not volume of base, instead it's volume of acid in milliliters. And we're adding acid into a base, so it's top down, and it's only, with base, the acid doesn't matter whether it's di or tri, it's what's in the first. The base is just, I don't know, uni base. So, and what is more important, weak base versus strong acid, right? At equivalence point, the pH is less than 7, so you want to make sure that it's something like this. Okay, because keep in mind the flat portion starts somewhere here and average of it is somewhere here. So this is your 7, so it must be at least less than 7. You don't have, again, this will be already drawn for you, so don't worry if it's not a perfect graph. So this is how you qualitatively draw a weak base versus a strong acid. All right, keep in mind the inflection point is not sharp if one of them is weak. Okay, and that's pretty much it. And I'll see you with 2 more videos, which I'm going to put it as 2 more content material. I'll put it as a single video if possible on buffers, which involves the Henderson-Hasselbalch, which you learned in the previous video, but we did try to go back to it during the lab. All right, so stay tuned.